Hi everyone, welcome to Differential Calculus. Today we explore lesson 3.2, the product rule and quotient rule. Number one, the product rule. The derivative of f times g is f times g prime plus g times f prime. Let's prove it. Derivative with respect to x of fg is limit h go to 0, fx plus h, gx plus h minus fx, gx over h, limit h go to 0, fx plus h, gx plus h, and we're gonna minus fx plus h times gx plus fx plus h times gx minus fx gx over h. From here, we can factor out the fx plus h. So have a limit h go to 0, fx plus h, and what we have left is gx plus h minus gx over h plus limit h go to 0. Similarly, for this case, we factor the gx, fx plus h minus fx over h. Yeah. Split the limit using limit law. So have a limit h go to 0, fx plus h multiply to limit h go to 0, gx plus h minus gx over h plus limit h go to 0, gx times limit h go to 0, fx plus h minus fx over h. As h go to 0, we have fx, and it is exactly the derivative of g, so g prime x plus gx, and the limit here is exactly the derivative of fx, f prime x. So that is it. We have shown that the derivative of f times g is fg prime plus gf prime. Wow. Let's do some example. Example, phi f prime x. We have fx equal root x e to the x. F prime x is root x multiplied to the derivative of e to the x plus e to the x multiplied to the derivative of root x times ex plus ex. Using the power rule, we have half of x to the negative 1 over 2. So we can factor out ex there, and we have root x plus 1 over 2 root x. Yay! Got the first one. In B, fx equal to 4 times x to the 3 ex. F prime x is 4x to the 3 multiplied to the derivative of e to the x plus e to the x multiplied to the derivative of 4x to the 3. 4x to the 3 times ex plus ex times 4 times 3 x squared. we can take out the common factor, and that is 4x squared e to the x, which would give us x plus 3. Awesome. Next, let's take a look at number 2, quotient rule. Quotient rule is the derivative of a quotient f over g is g prime f minus fg prime over g squared. A lot of people would remember this as low d high minus high d low over low square. Let's run through the proof. In the proof, we're going to use a different notation. First is, let's take a look at delta of the quotient f over g. So that is the small change in f over g, which is the same as f plus delta f over g plus delta g minus f over g. Yeah, a small change in the quotient. And from here, do the common denominator. We get gf plus g times delta f minus fg times f delta g over g times g plus delta g. Simplify this, we have a g times delta f minus f times delta g over g times g plus delta g. Let's consider the derivative with respect to x of f over g. This is the same as taking the limit as delta x go to 0. A small change in f over g divided by a small change in x, delta f over g over delta x, which is the limit of delta x go to 0. 1 over delta x multiplied to g times delta f minus f times delta g over g times g plus delta g. Now we're gonna multiply the 1 over delta x to the numerator. Limit delta x go to 0. G times delta f over delta x minus f times delta g over delta x over g times g plus delta g. So now we can move the limit in to the numerator and the denominator. G times limit delta x go to 0, delta f over delta x minus f limit delta x go to 0, delta g over delta x divide by limit delta x go to 0, g times g plus delta g. Well, the limit as delta x go to 0 of delta f over delta x is the very small change in x. That change is going to 0. So we have df over dx, g times df over dx minus f times dg over dx. And in the denominator, we have g times g. Well, as delta x go to 0, delta g also go to 0. And what we have here is g times f prime minus f times g prime over g squared. Yeah, we're gonna find all value of x where fx equal to x squared over 2x minus 1 have horizontal tangent. The term horizontal tangent tell us that the slope of the tangent is 0 or f prime x equal to 0. So that means we have to find the derivative and set it equal to 0 and solve for x. F prime x is, now this quotient, I'll use the quotient rules, low d high, 2x minus 1 multiplied to the derivative of x squared minus high x squared times d low, derivative of 2x minus 1 over low square 2x minus 1 square. And we have a 2x minus 1 times 2x minus x squared times 2 over 2x minus 1 square. Let's distribute everything here and simplify. 4x squared minus 2x squared over 2x minus 1 square. 2x squared minus 2x over 2x minus 1 square. And now we're going to set f prime x equal to 0. So when we set the derivative equal to 0, only the top equal to 0, not the bottom. That is the same as setting 2x squared minus 2x equal to 0. Factor of the 2x, we have x minus 1 equal to 0. And from here, we set each factor to 0. So 2x equal to 0, x minus 1 equal to 0. That gives us x equal to 0 as one value in which the graph have horizontal tangent. And another one is x equal 1. Let's take a look at decimals to confirm the answer. And we're going to graph the function x squared over 2x minus 1. And as you can see, there are 2 points in which the slope of the tangent line is 0. And one of them is at x equals 0. The other one is at x equals 1. Thank you for watching. I hope you found the content useful. Please like and subscribe to help the channel grow. I'll see you in the next video.